Have you ever wondered how our solar system, with its diverse planets and celestial bodies, came into being? This intriguing question has puzzled and fascinated humans for centuries. The formation and evolution of our solar system holds the key to understanding our place in the universe and the potential existence of life beyond Earth. It's a story that combines elements of cosmology, planetary science, and the very nature of existence itself. Join us as we embark on a fascinating journey through time and space to uncover the story of our solar system. Our story begins about 4.6 billion years ago in a dense cloud of interstellar gas and dust. This celestial nursery, full of cosmic potential, was the birthplace of our solar system. Now, you might be wondering, how did this formless cloud become the intricate system of planets and celestial bodies we know today? Well, it all started with something called the solar nebula. This nebula was an enormous spinning disk of gas and dust, where the magic of creation started to happen. Imagine a ballet dancer spinning faster and faster. As her rotation speed increases, she pulls her arms in and becomes a compact, whirling dervish. Well, our solar nebula was the cosmic equivalent of this ballet dancer. As it spun, it began to flatten and shrink inwards, forming a protostar at its very heart. This protostar was the early version of what would become our Sun, but the story doesn't end there. Surrounding this nascent star, the remaining gas and dust continued to swirl in a protoplanetary disk. Picture a cosmic pizza, with the protostar as the scorching hot cheese in the middle, and the cooler crust representing the protoplanetary disk. As this disk spun, particles within it began to collide and stick together. Over time, these clumps grew larger and larger, forming planetesimals, the building blocks of planets. It was like a cosmic snowball fight, where the snowballs kept getting bigger and bigger. Meanwhile, the protostar at the center of this maelstrom continued to heat up. Eventually, it became hot enough to ignite nuclear fusion, marking its graduation from protostar to fully fledged star. And thus our Sun was born. And thus, the stage was set for the creation of the planets we know today. As the dust and gas swirled around the young Sun, something remarkable began to happen. It was the beginning of a cosmic ballet, a performance that would span millions of years and result in the formation of planets. This process is not as simple as sprinkling stardust onto a canvas of space. It involves two key stages: accretion and differentiation. Let's break these down one by one. Accretion is rather like the snowball fights you might have enjoyed as a child. You start with a small clump of snow, and as you roll it around, it picks up more and more snow, growing larger with each revolution. In the same way, tiny particles of dust and rock in the protoplanetary disk around the young Sun began to stick together, gradually forming planetesimals, objects ranging from 1 to hundreds of kilometers in diameter. As these planetesimals continued to collide and merge, they grew into protoplanets, the precursors to the planets we know today. But the process didn't stop there. Once these celestial bodies reached a certain size, they began to heat up, leading us to the second stage of planet formation: differentiation. Differentiation is all about layering. As the protoplanets heated up, their interiors melted, allowing denser materials to sink to the center and lighter ones to rise to the surface. This process created a layered structure with a dense core, a mantle in the middle, and a crust on the outside. Now you might wonder why the planets in our solar system are so different, with rocky inner planets and gaseous outer ones. Well, this is due to the Sun's heat. Close to the Sun, only heavy elements like iron and rock could withstand the heat, forming the terrestrial planets: Mercury, Venus, Earth, and Mars. Further out, where it was cooler, lighter elements like hydrogen and helium could survive, leading to the formation of the gas giants: Jupiter, Saturn, Uranus, and Neptune. In the vastness of space, our solar system, with its unique set of planets, was taking shape. From a swirling cloud of dust and gas, the stage was set for the cosmic ballet that would give birth to our home in the universe. Over billions of years, our solar system has undergone significant changes. The first few 100 million years of our solar system's life were not exactly peaceful. In a period known as the Late Heavy Bombardment, our young planets were pelted by asteroids, creating many of the craters we see on the Moon today. This chaotic era was followed by an epoch of migration. The giant planets, Jupiter, Saturn, Uranus, and Neptune, did not stay put where they formed. Instead, they moved around, their incredible gravitational forces causing mayhem. Jupiter, the largest of them all, caused the most disruption, its gravity flinging asteroids and comets around like confetti. This migration of the giants had a significant impact on the layout of our solar system. The asteroid belt, that rocky ring located between Mars and Jupiter, is thought to be the remnants of a planet that couldn't form due to Jupiter's disruptive influence. And beyond Neptune, the icy bodies of the Kuiper belt, including Pluto, are thought to be remnants from the solar system's early days, pushed to the outskirts by the migrating giants. Over time, these events have shaped the solar system we know today. The planets have settled into their orbits, the asteroid and Kuiper belts remain as reminders of our turbulent past, and the scars of asteroid impacts tell a story of a chaotic infancy. Our solar system has truly been a cosmic battlefield, constantly changing and evolving. Fast forward to today, and our solar system is a bustling neighborhood of planets, moons, asteroids, and comets. Our cosmic family, birthed from a spinning disk of gas and dust, has matured into a diverse and complex system. Each member, from the sweltering Mercury to the icy rings of Saturn and the dwarf planet Pluto, brings its own unique characteristics to our cosmic neighborhood. The formation of our solar system, a dance of matter, gravity, and time, has resulted in 8 distinct planets. Each one has been shaped by its own unique set of circumstances, leading to a variety of atmospheres, geological features, and even potential for life. The asteroids and comets, often referred to as the leftovers of this formation process, serve as a window to our past, revealing clues about the early solar system. The story of our solar system is a testament to the power of time, gravity, and matter. It's a story that reminds us of our place in the vast cosmic landscape,